Fill in the box to make each equation true. So now we need something plus 8 equals 2. So I know that I'm taking a number and adding 8 and I'm getting 2. So I know that that number is going to have to be negative. So it's going to be negative 6. And if we see that on a number line, we get 2 right here. And we're at negative 6 here. If we start at negative 6 and we add 1, 2, 3, 4, 5, 6, 7, 8, we get to positive 2. Here we're at negative 5 minus something equals negative 18. So that, let's see, I start at negative 5 and I'm going to negative 18. So I go negative 5, negative 6, negative 7, negative 8, negative 9. This is negative 10. Negative 11, negative 12, negative 13, negative 14, negative 15, negative 16, negative 17. Here is negative 18. So I have to subtract 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So negative 5 minus 13 gives me negative 18. And here we're at negative 2 minus negative 15. So remember, subtracting is just adding the opposite, or adding the inverse. So that's the same thing as negative 2 plus positive 15. So negative 2 plus 15, let's see, if I add negative 2 plus 2, then that gets me to 0. And I have 13 left over. So that's 13. Something times negative 4 equals 45. So here I need to multiply, I can just say 45 divided by, or negative 45 divided by 4. And then if I multiply by negative 4, it cancels that out and I'm just left with 45. Negative 10 times 0 equals 0. 0 divided by 5, 0 divided by any number is 0. Is the following statement true? Explain why or why not. So this statement says 2 is greater than 2. 2 is greater than 2. Is that true? Not true. Because 2 equals 2. It's not greater than. Okay, examine the pile pattern below. Sketch figures 4 and 5 to the right. So here I see that figure 1 has, let's see, 1 right here and 1 right there. This one has 2 right here, 2 right there, 3 right here, 3 right there. So it's adding 1 on the top and 1 on the right each time. So figure 2 has this 1 square is staying the same, and then it has 3 and 3. 2 and 2, 1 and 1. So figure 4 is going to have this 1 block, and then it's going to have 4 tiles right there and 4 tiles right there. Because it has the 1 block and then 4 and 4. Figure 5 is going to have the 1 block and then 5 right here and 5 right there. 1, 2, 3, 4, 5, 1, 2, 3. So it has the 1 block, 5, and 5. How does the pattern grow? Explain in complete sentences. So it grows by adding 1 tile to the bottom row and 1 tile to the top of the column. So remember, a column is up and down and a row is sideways. How many tiles will there be in figure 100? So I noticed that the number of tiles is the same as the figure number. Like figure 2 has 2 right here, 2 right here. Figure 3, 3 right here, 3 right there. 4 is 4 and 4, 5 and 5. So figure 100 is going to have the one square in the middle, and then it's going to have 100 tiles here and 100 tiles there. So figure 100 is going to have 100 plus 100 plus 1, which is 201 tiles. Using the number line below, place a point for each number. Part A has been done for you as an example. So A is 2 and 1/3, so we went over to 2 and then a little bit. B is negative 2.7, so I go negative 2, and then 0.7 is closer to negative 3, so that's right about there. C is 0.9 minus 0.4. So I'm going to start at 0.9, which is right about here, just before 1. That's 0.9 minus 0.4, so that's going to be 0.86, which is right about here. Negative 0.2 is less than negative 1/2, so that's right about here. 33.13% of 12. So basically that's 1/3 of 12, which is 4. And then 7/10 plus 2/3. So now we need to convert those so we can add them to a common denominator. So we'll multiply this side by 3/3 and this side by 10/10. And we'll get, let's see, 21/30 plus 20/30 equals 41/30. So I have 41/30 pieces. So 30 of those 41 gives me a whole. And then 41 minus 30 is 11, so I have 11/30 left over. So I have one whole, and then 11/30 is almost about 1/3. So I go one whole and then about 1/3, and that's F. The pattern at right is composed of nested squares. Draw the next square in the pattern. So let's see, we have one, the side length of 1 is the smaller, 2 is the bigger, 2 bigger, 3, 3, 4. So the next one is going to have an inside of 4 and an outside of 5. Find the area of the shaded region. So that's this. So the area of the big square is 5 by 5. 5 times 5 is 25. The area of the little square is 4 by 4, which is 16. So I have to take the big square and subtract the little square to find what's left over. So what's left over is 25 minus 16, which is 9 units squared. Riley was monitoring the growth of his favorite tomato plant and collected the data at right. Graph Riley's data. So let's see, we're going to put time on the x-axis, that's the independent variable, and height on the y-axis. So first I'm going to make my scale. Let's see, time needs to go from 10 to, it needs to go all the way to 23. So maybe I'll go by 2s, 2, 4, 6, 8, 10. 2, 4, 6, 10, 12, 14, 16, 18, 20, 22, 24. I'm not going to mark every single one. And then height, I can just go by ones, I think. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 15. So let's see, my first one is 10 days and 3 centimeters. So that would be right here. 14 days and 4.3 centimeters. 4.3 is right about there. 18 days, 7 centimeters. 5, 6, 7. 21 days, 8.9 centimeters. So 21 is halfway. 8.9, let's see, that's 9. Just below 9. 23 days and 11.4 centimeters. What can you tell Riley about his plant based on the data? So it looks like his plant keeps growing faster and faster and faster. It looks like this is a curve. Like his plant is not growing linearly, it's growing in a curve. So it looks like grows more and more each day. It is growing faster every day. That's what it looks like. It's not growing at the same amount every day, because if it was growing the same amount every day, it would be a line like this. But it's growing more and more every day, so it creates this curve.